Hey everybody, this is Dr. Duncan with BI 101, and for our lab section we're going to be doing some graphing, creating species area curves, and we're going to do this for at least one lab depending on the semester, maybe a couple of labs. And so I wanted to make this online tutorial for you so that you can watch this on your own when I'm not around and get a little help on how to create a species area curve. So species area curves are used for showing patterns in data and data that you collect on ecosystems, for example. And there's many different ways to use data you collect from ecosystems, depending on the type of data that you have, depending on the questions that you have, and so forth. In this case, we're interested in figuring out what is the total number of species found in a particular ecosystem. And that's what we're going to use our species area curve for. Now, let me break this plot down for you here a bit so this starts to make more sense. Let's look at the x-axis. That's your horizontal axis at the bottom down here. What we see are the cumulative number of quadrats. So what is a quadrat? You might have learned by now that a quadrat is an ecological term for a study plot. Usually quadrats are 1 by 1 meter square, sometimes they're 10 by 10 meters square, or sometimes 100 by 100 meters square. It all depends on the type of question that you're asking. So these are quadrats, and basically within the quadrats, in this case, someone has gone in and counted the total number of species that are in that quadrat. In BI 101, we usually do this with plants because plants are easier to study. They don't fly away. They usually don't bite you, things like that. So we're going to think about plants with this example. And I'll show you some, and these data are actually from some actual study data looking at plants. So what do we mean? So that's what a quadrat is. What do we mean by cumulative number of quadrats? Well, that just means that during the course of your study, you sample your first quadrat, and then you move on to your second quadrat, and so forth and so on. And that's what we mean by cumulative number of quadrats. By the time you've done your 10th quadrat, you would be up to here on the plot. Now, in this particular study, you'll see that the last dot here represents the last quadrat that was sampled. So there's only a total of 16 quadrats in this particular study that we're graphing the data from. Okay, so that's what we mean by quadrat. That's what we mean by cumulative number of quadrats. Now on the y-axis, we've got cumulative number of species detected. What this simply means is that as you go through the course of the study, how many species have you found, not just in any one quadrat, but in all the quadrats together. And that's why this number only goes up. You might have noticed that sometimes it will go up just a little bit, like between quadrat 3 and 4. Sometimes it will jump up a lot, like between quadrat 4 and 5. And sometimes there won't be any change at all. But all of this to say that the cumulative number of species detected always goes up or stays the same. It never goes back down. Now, I'm going to illustrate what this means in more detail by looking at some data in just a minute, but I want to point out a few more things about how a species area curve works. What you're looking at here is a curve that I have superimposed to try to illustrate the overall shape of the curve. I hand drew this line using Microsoft Excel, so it's not exactly. Okay, I guess that was a contradiction. I used a function in Microsoft Excel where I could tweak how this curve looks like, so I didn't exactly hand draw it. It's not exactly how I wanted it, but it's close enough for teaching you guys this today. Now you'll notice that this overall red line doesn't go, this is not connect the dots. It doesn't zip through all the dots. It actually sort of averages distance between adjacent dots. So for example, in this span right here, I had this one dot that kind of fell out kind of low, and then this one that was up kind of high. So I kind of split the difference there as I tried to make my way up as I drew the curve up to this zone here, where these guys are. Ideally, this part of the bend in the curve would be a little bit farther down there, but I couldn't quite get it to work with Excel to do that for me. On this part of the graph, obviously there's no curve at all because we're not adding any more new species after quadrat number 9, it looks like. Okay. This will be part of your drawing, your completion of creating a species area curve, is drawing one of these lines that shows the overall trend in your points, in your data. And remember, it's not connect the dots. You're kind of averaging the differences between the points, between these dots, to illustrate the overall curve. Okay, now let's get into the mechanics of how these curves are created. All right, this is a data table where for the 16 quadrats as part of the study, we've got the quadrats listed across the top, 1 through 16. And remember, those are just study plots, in which, in this case, we've gone in and counted the number of, or we've tallied like what species of plants are there. And then on the far left column, we've got a list of all the plant species that are detected in the study. Now, thus far, I've only got displayed for you here the species that are found in quadrat number 1. I'll show you the rest of the data in just a moment. And in quadrat 1, if you were to count up all these X's, you would see that there's a total of 17 X's. That means that there were 17 plant species that were detected in quadrat number 1. They include what I also want to point out, these are the scientific names. That's why these words look so familiar or unfamiliar to you guys. Instead of like roses and things like that, it's got the actual scientific names. Okay, so quadrat 1 had a total of 17 species. Now let's look at the overall data. That's this next slide. Here we go. You see lots of X's. Every time an X shows up, that means that that particular species was found in that particular quadrat. So for example, in quadrat number 13, it had Digitaria sanguinalis, and it had Coniza canadensis, and Poa compressa, and Meliotus alba. Sorry, I'm not a botanist by training, so I'm struggling with those names there. But that's what those X's represent, just for arbitrarily picking quadrat number 13. Now, you might have also noticed and might be wondering why some of these squares are highlighted. And if you take a look at it carefully, you'll notice that the squares that are highlighted are the first appearances of these species in the study. Okay, so for quadrat number 1, because it was the very first quadrat that was sampled, every species that was found in that quadrat was the first time that it was encountered. It's kind of like a no-brainer there. In quadrat number 2, you'll notice that all the X's here, most of those X's in column number 2 are of species that were already found in quadrat number 1. But this one right here that's highlighted in green, if you're colorblind, you can see I'm circling the cursor around it. This species, Trifolium praetesni, this species showed up in quadrat 2 for the very first time in the study. It was not in quadrat 1. It does show up in some of the other quadrats, but quadrat number 2 was the first one. Moving on down the column here for 2, we had 4 more species that showed up in quadrat 1, and then 2 more species that show up only for the first time in quadrat number 2, and so forth. Okay, so every time you see one of these highlighted cells like this that's a bright color, that's the first time that each species shows up. And you might also start to notice, if you look at this graph, that as you go farther along, as more time elapses and we add more quadrats to the study, you start to see fewer and fewer of these highlighted cells. That's because these first few quadrats are picking up on the most common species, and then gradually picking up on the less common species. So that by the time we get to quadrat number 10, and from 10 to 16, we don't see any more new species. All the species that are in this ecosystem have showed up in quadrats 1 through 9. Okay, now let's roll back and take a look at what that looks like on our species area curve. So I've just gone back to the very first slide. These are the actual data from that table that I just showed you, that data table that I showed you. And now I think you might have a better understanding of what it is that we're looking at. So in quadrant number 1, there was a total of 17 species. Every one of them was new. So I plotted my dot here at 17 species. In quadrant number 2, rolling forward, there were 3 new species. This green one, green one, green one, referring to the cell colors there, those 3 new species. So 17 from before plus those 3 equals 20. So let's go back up to our plot, and that's why there's a dot there at 20. Looking ahead, we see that in quadrant number 3, there's 2 new species that are added. So I suspect that if we go back here, we'll see 2 new species. And yep, what do you know? There they are, highlighted in purple. Okay. So by now, hopefully you're getting the gist of this, is that what we are graphing up here is the total number of species detected in the overall study. Okay. These dots are not graphing the total number of species in each quadrat. Otherwise, it would be going up and down and up and down and up and down, because every quadrat would be a different number. Okay. So the value of doing this graph, the species area curve, shows us an estimation of how many species are in the ecosystem. And reading here on the y-axis, up here at the top, where we're not getting any more, the top of the curve, where we're not getting any new species, reading over here like that, it looks like there's 33 species in this ecosystem. And you might be wondering, if I hit 33 species at quadrant number 9, why did whoever did the study, why did they keep sampling? Was this over here, all these quadrats 10, 11, 12, 13, 14, 15, 16, were these a waste of time? Absolutely not. Because imagine if you had stopped right here at quadrant 9 or 10 and you only had the first 10 dots, you wouldn't know whether it flattens out or not. You wouldn't know if it's going to keep going up and up and up. And that's why you need to keep sampling until you get to the point where your curve flattens out. And when that curve flattens out, then you know that you've got a solid, trustworthy estimation of the total number of species in your ecosystem. Okay. So that's what we're going to be using species area curves for, or at least one application of it. Now, let me show you a way that you can keep track of the data that are in these big tables like this. How do you turn this? I guess what I'm trying to say is, how do you turn this, all these data here? I don't know if you guys, I'm videotaping this outside, and that's why there's all these weird noises, like my neighbor and his enormously loud sneeze that he likes to do every so often. I don't know I hope you guys got to hear that. That was epic. All right. So the question is, how do we turn this into that graph? So here's how you do that. Make yourself a little chart where you've got your quadrat numbers here, and then have a column for just the total number of species if you want. You don't have to necessarily do this, but for some of the lab exercises we'll do in BI 101, you will need this column. So that would be total number of species that are in the plot. So plot quadrant number 1, sometimes I call them quadrats, sometimes I call them plots. Quadrant number 1 had 17 species, number 2 had 14, number 3 had 15, number 4 had 15, etc., etc. Okay, I haven't obviously filled all this out, I'm not going to. And this number down here for 16 should read 33. I don't know why it reads 34. Apparently somebody around here can't count. Okay, that would be me. The next column here is the number of new species, and that's what I've been emphasizing all along here. This is the number of new species that are found in a quadrat for the first time for the study. And so in that first quadrat, all of them were new, and then there was quadrat 2, there was 3 that were new, then 2 that were new, then 1 that were new. And of course, by the time you get down to here, as we saw, this is going to be 0. Number of new species is going to be 0 for after, I think it was plot 10 all the way to 16. And then this number here represents the cumulative number of species. Now let me remind you, I'm going to scroll back a few slides. That's what you're plotting here on the y-axis. So going back to our the slide here, this cumulative number of species, this is the column, this is the golden column here that is what you're going to be graphing. And you can get this simply by, for the first quadrat number, the cumulative number of species is also the total number of species. But then for quadrat number 2, you got to take that 17 species from before and then add the 3 species that were new in quadrat number 2, and 17 plus 3 is equal to 20. So by the time we're done with quadrat number 2, during the course of the study, we've detected 20 species, and so forth and so on. And by the way, if you haven't figured it out, these colors here, yellow, green, purple, and red, correspond to these colors in these cells, just to help you match that up. Okay, one more slide here to help you wrap that up. I've drawn over here on the left the species area curve as I was building it out for the first 4 quadrats, and I wanted to illustrate how these are the 4 numbers in this far right column, cumulative number of species, that we're graphing over here. If you graphed this column or this column, you're going to get something completely different that's not going to look at all like this. It's going to look very different. So if you wind up creating a graph that doesn't look something like this, then you're probably graphing the wrong thing. So again, it's this last column here that we're interested in, and that's what gets graphed over here. Okay, I hope that helps you understand how to build a species area curve. If you obviously you can rewind and rewatch all you want, but if you are still stumped, have any questions, be sure to reach out to your lab instructor, or in semesters when we have it, reach out to your teaching assistant. Okay, that's all, folks.